Welcome to this tutorial on the GNU Octave Scientific Programming Language for Beginners. This is a full tutorial on Octave, whether for mathematics or for general programming use. The first part of the video will discuss Octave for mathematics, which is the language's most common use, and the second part of the video will focus on Octave as more of a general purpose programming language. As you see in this agenda, we are going to be covering a lot of ground, so if there's a particular topic that you need to know about more quickly, do take a look at the timestamps in the description. In the first part of this video focusing on mathematics, we will cover getting set up with Octave directly from your web browser without having to download anything, though note that everything we go through today will work just as well if you're using Octave downloaded onto your machine. We'll then talk about how to do basic mathematical operations with Octave, some of the built-in mathematical functions that come with Octave to do more complex mathematical operations, some of the pre-made variables and commands that come with Octave, including the mathematical constants, which are really just pre-made variables, and then how to set your own variable to store data. And then we'll wrap up the first part with the reason that I suspect many of you are using Octave in the first place, which is scalars, vectors, matrices, how to make them, transpose them, do mathematical operations with them, and access elements of them from them with index expressions. And so the matrix part will take up a pretty big chunk of it. If that's not something you're interested in, then you can certainly skip over it with the timestamps. The second part of the video will focus on Octave as more of a general purpose programming language, and we will discuss strings, which you can think of as plain text, how to make them, how to manipulate them, how to get input from the user, and how to choose what type of data that input comes in as, whether as numerical data or as a string, how to write your own programming function to have your program execute a block of code, writing conditional, that is to say if-then statements, a few different kinds of loops, for, while, and do-until statements, and then we'll wrap up with how to add comments inside your code that are just for a human reader. So, of course, there is a lot to cover, so let's dive right in. And you can certainly download Octave directly onto your computer if you like, and we'll put a link in the description to Octave's website for more detail on how to do that if that's what you want to do, and you can certainly follow along with everything that I'm going to say by doing that. But instead, that's not what I'm going to do for this tutorial. Instead, I'm going to use Octave directly from my web browser without downloading anything, and to do that, I'm going to use a website called cocalc.com, and that's COCALC.com. And as you see, it's a website that's designed for kind of math with software. You can teach classes with it, etc. I'm just going to go to run CoCalc now. You can make an account if you want, but no need. So I'm going to run CoCalc, and it's going to take a second to load, but you'll see there are going to be several different options for programming languages that they offer that you can use. Like Python 3, the Sage Math language, Julia, etc. But I'm going to scroll down to Octave right here and click it, and that's going to allow me to start working right away in Octave. And you see in the corner here, it says Octave. And so now I'm going to zoom in just a touch, and we are ready to roll. So this is a Jupyter notebook. If you're not familiar with one, it's just kind of a way to execute cells, blocks of code, cell by cell, so to speak. One nice thing about CoCalc is it comes with these snippets of code, so like some pre-written code that, if you are interested in doing like a mesh grid or like some nonsense. And so that's one nice thing, but let's just start with something much more basic, the basic mathematical operations. You, in essence, using Octave as your calculator, and we're going to talk first addition, subtraction, multiplication, division, exponentiation, and those are just what you would expect. Let's put an example of each into some cells in our Jupyter notebook. Let's do 3 plus 4, 3 minus 4, 3 times 4, 3 divided by 4, and then let's do two different ways to raise to the power. 3 to the power of 4, 3 to the power of 4. Okay, so as you see, addition is just a plus. In fact, the addition, subtraction, multiplication, and division are more or less what you would expect. Plus, a sign, minus sign, an asterisk, and a slash. And then exponentiation can either be with this caret, which on most keyboards is Shift 6, or you can do it in more of a Python style with a star star. To run the cells, to run any individual cell, you can use Shift Enter, and that'll give you the answer from the cell. Or to run all the cells, you can go to cells right here in your menu, and then run all. And that'll run all the cells. So, as you see, this did all of these operations, just as you might expect. Notice that this gives you several decimal points, including the ones that we don't necessarily use. That we'll talk about that when we talk about formatting your decimals later. And also notice that to the power of either of these gives you the same result. So you might be more comfortable with the caret, especially because it's more similar to how it might be written by hand. But of course the star star will also work just fine. And, you know, if you're coming from a Python background, you're probably more comfortable with the star star. All right. You will also perhaps see, and we'll see later on, these operations with like a period before them. So, you know, like a period plus or a period star. Right now, it's just going to give you the same thing if you do that. That in a nutshell, without the period, will be operations you can do from matrix to matrix. With the period would be like element by element within a matrix, but we're not yet dealing with the topic of matrices. So these will give you the same result regardless of whether you have the period for these kinds of simple operations. All right, so one trick to delete a lot of cells in the Jupyter Notebook is just to click on the cell and then on your keyboard click DD. So I'm just going to do that a bunch and it'll clear everything out. You can also hit escape and select the cells you want to clear and hit DD to clear them all. So you'll see me clear these out from time to time. So one of the other operations that's a little less intuitive is the backslash, and I just want to show you that really quickly. We saw that's 3/4 is like 3/4, 0.75, but the 3/4 is actually a reciprocal. It's going to go 4 divided by 3. And so if you do that, you'll see it's 1.333, which if you did 4/3, it's going to give you the same thing. And so that's just one trick, is this backslash is itself an operation. You can think of it as doing a reciprocal. Now, if you want to do something a little more complex than just these operations, you can use what's called a function. And in programming, a function is some pre-written bit of code that you can use to perform a certain task. You can write your own, which we'll discuss later on in this tutorial, but for mathematics, Octave comes with really a very large number of functions that can perform all kinds of different mathematical tasks for you built in. And so an example of a built-in function in Octave is plus with parentheses written like so. And the syntax for functions is usually the name of the function followed by parentheses. And then what goes inside these parentheses is called an argument. And sometimes functions can take many different arguments inside the parentheses followed by a comma. Sometimes they only take one. It depends on the function. So taking the function plus, for example, this is just another way to do addition. We saw earlier that you could write 3 plus 4, right? And it would add those two together to get 7. And of course you could add in a bunch of numbers together. 3 plus 4 plus 3 plus 8, for example. It'll add them all together, no sweat. But this function is another way to do that. It will take arguments and then sum up that list of arguments separated by commas. So if you want to do plus 3 comma 4, this is another way of saying 3 plus 4. And you see it gives you 7. And if you wanted to do 3 comma 4 comma 3 comma 8, and then shift enter to run the cell. And you see it's the same exact thing. It adds these all up, and it gives you their sum, which is 18. And in fact, most of the basic operations that we just discussed earlier have an equivalent function. So I'm just going to show you a few. Let's do plus 3, 4, gives you 7, right? Minus 3, 4, and we'll just run them all, times 3, 4, power 3, 4, r divide, and I'm just going to write them out now. Actually, why don't I do L divide 3, 4. Okay. So if we run all of these, what's going to happen? These are going to do 3 times 4. No, I'm sorry, 3 minus 4 for minus. For times, it's going to be 3 times 4. For power, it's 3 to the power of 4. And then I'll show you what r divide and L divide do in a moment, but in essence it's going to do what we saw before with the slash and the backslash. So let's run all. Okay, so here we have 3 plus 4 is 7, 3 minus 4 is -1, 3 times 4 is 12, 3 to the power 4 is 81, and then r divide is 3 over 4, L divide is 4 over 3. Okay, and r divide, you can think of like the forward slash. It's called quote-unquote right division. L divide is the backslash quote-unquote left division, and yes, r divide does go from left to right, and L divide does go from right to left, so it's not necessarily intuitive, just something you'll need to get used to. And just a note, these functions are actually equivalent to the period operator, so like 3 period plus 4 or dot plus. And again, that's not important yet, but it is something that I want to make sure is clear for when we talk about matrices, so that's just something to keep in mind for later. Okay, but there's many other different types of mathematical functions that come with Octave besides just basic mathematical operations. So there's so many others, we could never cover them all in one video, but I'll just show you some examples so you get a taste of what's out there. For example, rounding. You can round to the nearest integer with round, so say round 4.6 or round 23.3. If you run this cell, shift enter, you see round 4.6, it'll round it up to 5. If you round 23.3, it'll round it down to 23. Okay, and you can also do bankers rounding with round B. If you're not sure what bankers rounding is, I'll put a link to our video on it. We have a whole video on it, though from a Python perspective, because it is the default in Python 3. But bankers rounding is going to half the time round 0.5s up and half the time round 0.5s down, just to prevent you from having too much bias in a large data set. And so if we do bankers rounding of 15.5 and 16.5, it's both of these are actually going to round to 16. So they, as opposed to if it was just round, they would both round up. I'll show you. See, so that's one difference. Another few examples, just to show you some more. If we have, I don't know, factorial, you can do a factorial of 4, and that's gonna give you 4 times 3 times 2 times 1. It'll just do it for you. It's the same as if you were writing by hand, like 4 exclamation mark for factorial. You can do greatest common divisor, GCD, and if you feed in arguments like 18, 12, and 81, it's going to give you 3, because 3 is the greatest common divisor between these three numbers. Okay, and so I don't know, if you wanted to find the hypotenuse of 2 sides of a triangle, a right triangle, you don't have to do a squared plus b squared equals c squared. You can just do hypot, and then if your sides of your triangle are 3 and 4, and that's what's called a 3, 4, 5 triangle, the hypotenuse is going to be 5. because 9 squared, right? So I'll just show you, because 3 squared plus 4 squared is going to be 25, and then the square root of 25 is just 5. And so you don't have to go through all that, because you can just find the hypotenuse with a function, hypot. And this is just to show you the syntax. I'm not expecting, I know I'm throwing these at you one by one. This is not to say, and now I'm going to tell you how to find the hypotenuse. I'm just trying to show you the syntax of how these built-in functions work, and then you can go to the documentation, the link to which is in the description, to see, what you might want to do, and there's probably a function for it. So I don't know, like square root, sqrt 4, or nth root, which, if you do like 2, 7, 4, 4, comma 3, that's going to take the nth root of 2744, and then what root? It's going to take the cubed root, because we put in as our second argument 3. So if we run this cell, it'll show you the square root of 4 is 2. It'll show you the nth root, which is the cubed root, because the second argument is 3, of 2744 is 14. And we could be here all day if we went through all these built-in functions. But do take a look at the documentation. If you have some particular mathematical operation in mind, it's not unlikely there's already a built-in function that can handle it. And one note, if you're planning to do the trigonometry, the sine, cosine, tangent, those take their argument in radians. But there are also functions that convert degrees to radians and vice versa. So keep all that in mind and take a look at some of these built-in functions. They're all very handy. Next, I want to show you a special type of function called a command. A command does not have arguments in parentheses, but otherwise you can think of it similar to the functions we just saw. It's an instruction to do a particular task. Commands usually come up with regards to when you need to do something in connection with Octave itself. So for example, if you need help, you can write the command help with the keyword help, and then no parentheses, just space, and then the name of the function or whatever else you need help with. So earlier we saw hypot as the name of a function for getting the hypotenuse, and if we do help space hypot, it'll explain it. Hypot is the built-in function. It'll compute the square root of the squares of x and y. So x squared plus y squared, the square root of the sum of the squares of x and y. In other words, x squared plus y squared equals c squared, and then it'll do radical c, right? And so that's just an example. You can also do help, which is help with the help command, and then it'll explain what to do and how to use the help command. There's other commands, including ones you'd be more likely to use on a terminal screen than a Jupyter notebook, like to clear. You can do CLC, and that will clear your terminal screen if that's what you were using. News, which can give you the latest news on Octave, for example. So those are, play around with it, and again, take a look at the documentation, but those are just some of the commands and how commands kind of look. Now I want to shift gears and talk about variables, and I don't necessarily mean variables in the math sense of the word, but the programming sense of the word. Variables are a means to store data. You can think of it, it's a... You'll give something a name, and that name can be a series of letters, numbers, underscores that represent some data, which can be a number, like we'll see first, and that'll be what we work with now. Matrix, which we'll use later, or plain text, what's called a string, which we'll use even later in the video. And, first I want to show you some of the built-in variables, and then we'll make our own variables. So there are several constants in Octave which are really just built-in variables, like pi, e, several ways of representing the imaginary numbers. So I'll just do it all in one cell. Lowercase I, lowercase j, capital I, capital J. inf NaN, which is not a number. And if we ran all these cells, you would see it'll print out as the output what is stored inside of these variables. The variables pi and e are, of course, irrational numbers. Are going to go on forever, but you know, it's only going to display to a certain number of significant figures. I'll show you how to reformat that in a little bit. But there is some approximation of pi that's stored inside this variable pi, this pre-written variable, this constant. Same with e. And then with the imaginary number, some people like the lowercase I. That's how you would typically see it in mathematics, and you see is how Octave defaults to do it with the output. If you're coming from a Python background, you probably like the lowercase j, because that's how Python does it and how some disciplines do it, like engineering. And you can also do the capital I or capital J if that's how you want to do it. Infinity is just what it sounds like. It's kind of like a numerical representation of infinity. Not a number is a numerical representation of kind of the concept of not a number. I do have a video that goes into those concepts more depth in Python, so I'll put a link to that if you're curious what not a number in infinity as represented in a constant could mean. But I won't go into it too in depth. But those are some pre-made variables that are in Octave. So here's an example of a variable in action and why variables are so powerful. Instead of writing out the digits of pi, if you wanted, you know, we can just use this variable pi in our calculation as a stand-in for that, because it contains stored within it the computer's approximation of the value of pi. So for instance, if you knew that the circumference of a circle equals pi times the diameter, you can calculate the circumference of a circle with a diameter of 4 by typing in pi times 4 and then running the cell with Shift-Enter, and it'll calculate that circumference for you, because c equals pi times diameter. There's your circumference. And so you don't have to type in 3.14159, whatever. You know, you can just type in simply pi times 4. It's stored inside a variable, and it's very easy to use. So next I want to talk about just making your own variables, because the pre-built variables are all well and good, but things get really powerful when you start making your own variables. And you can do that by writing the name of the variable that you want. It can be any name, just no spaces, and it can't start with a number. So it can have underscores, like cool number. It can be the name of a variable. And let's store inside that with an equal sign the number 2. So that's the equal sign. It's not a mathematical equal sign. It's more like a signifier that we're going to store some data inside this variable, and that data we're going to store is the number 2. And in fact, if we run the cell, Octave is going to give that as our output as well. Sometimes, especially if you're defining a bunch of variables, that can get a little annoying. You don't actually want it to give this output, so you can suppress the output with a semicolon. So you'll see us doing that a lot in this video. And it stored the number, but there's no output. So later, if I want to later in my program print out what cool number is equal to, you can just type in the variable later and cool number is 2, or if you wanted to do cool number plus 4, it's just going to read this as 2 plus 4 because it knows that the cool number has stored inside it the number 2. Excuse me. So here's a cool thing. We've been getting this answer equals 6, right? ANS equals 6. This is actually a variable called ANS, right? And it's assigned the value 6. And so if we just wanted our answer, it's going to have 6. And in fact, if you wanted to do that plus, 6 or something, it's going to give you 12 because it's going to remember, hey, I assigned this value to be 6. And then later, because your variables can change, and in fact, it's often something that you want to do is to assign something to a variable and then change it later in the program. Now, ANS actually doesn't equal 6 anymore. Now it equals 12 because you see right here, it just did this ANS equals 12. It assigned 12 to ANS. So now if you do ANS plus 6, it's going to give you 18. Okay, so that's just one cool thing. This isn't just telling you what the answer is. It's actually putting the answer into a variable so you can use it later. In fact, you can, even within the same cell, change your variable, and that's often, like I said, something you want to happen. So if your variable is called num equals 3, and then I'll suppress it with a semicolon, and then you do num equals 3 plus num or something, your variable is actually now going to be 6, not 3, even though before it was 3. It was 3, and then it added 3 to it to make it a new variable, which is 6. Okay, so it'll change what the variable is, no problem. And then if you do this in a new cell and do like num to the power of num or something, it'll now do 6 to the power of 6, right? Because 6 to the power of 6 is the same thing. So that's one really nice thing. Okay, so that's kind of the basics of math and storing things into variables, which is all the prerequisites I think we need to start talking about the main attraction of Octave, what Octave is perhaps best known for, vectors and matrices. Let's run through some vocab so that we're on the same page with what I'm going to be talking about. Matrix, or the plural matrices, is a rectangular array of numbers arranged in rows and columns. And in fact, Octave is very, very, very based. It's heavily based on this idea of matrices, and it's one of the biggest and most important things that Octave is used for is matrices, is manipulating this rectangular array of numbers. And in fact, matrices are used all over data science and linear algebra and all kinds of different applications. Anytime you have an image that's full of pixels, you can think of each of those pixels as a matrix. It has all kinds of applications, and so this is a matrix, and the order of a matrix is its rows by its columns. So this above matrix is a 3 by 4 matrix because it has 3 rows, 1, 2, 3, and 4 columns, 1, 2, 3, 4. So you would say it's of the order 3 by 4. It's a 3 by 4 matrix. An element of a matrix is any number that's inside of a matrix, or anything that's inside of a matrix. But since we're only going to be talking about numbers in this section, we'll say number. And so, for example, 23 that I have highlighted here is an element in this matrix, as is the 0 or the negative 48 or whatever. Each of them is an element in a matrix. Vector is a matrix with only one row or only one column. So this is only one row, so it's a 1 by 4 matrix. This is only one column, so it's a 3 by 1 matrix. And it's a vector, and so that's what's usually called. A scalar is a matrix with the order 1 by 1. It's just one numeral, so like 8 is if this were inside a matrix, but it's a matrix of just one element, it's called a scalar. Okay, so that's just some of the vocab just to help make everything that we're about to go through a little easier to follow, especially if you're new to matrices. So how do we make a matrix in Octave? Well, we do it just as we did before with a number. We can make a variable and assign a matrix to that variable in brackets. A commonplace notation, though not necessary, but a commonplace notation is to assign a capital letter to denote a matrix. For example, A equals, and then and then the way we do a matrix in Octave is to have brackets, and inside these back brackets we put our matrix. And there's a few different ways we can write this, any of which will work. One is to separate out the matrix, the elements that are on a same row by commas, and then designating the next row with a semicolon. So if we have A 8 7 2 0, that's one row of the matrix, semicolon to show we're about to go on to the next row of the matrix, 9 73 23 1, semicolon for the next row of the matrix, negative 48 2 1 29. Let's run the cell, and you see this made our matrix. It has our rows that we wanted. Okay, each of these is one of the rows, and it has our columns that we wanted designated by our semicolons, and that's one way to do it. Now, there's other ways to write this within the bracket. The brackets are necessary, but you could, instead of commas, separate out these with just spaces. So if you just had spaces here instead of commas, that's fine too. It'll work just fine. So let's run the cell, and you see it gives you the same exact matrix. You can also separate out the elements that are going on to a new row with an entire new line using your Enter key on a PC or Return on a Mac, like so. If we have B, capital B, equals, in brackets, 4 6 8 1, and I could be using commas here if I wanted to separate, doesn't matter. Enter. And then say 483, 39, negative 3, 3, enter, 19, 4, 1, negative 93. And then if we ran that cell, there it is, our matrix works just fine. Now you can also tab in to make this, you can indent, it won't affect your matrix, and then it's lined up and looks a little neater, perhaps. So run that, works just fine. There's your matrix. So that makes it visually, as you're writing it, perhaps look a little bit better while you're inputting it. And you can mix and match. You can have a semicolon here, or you actually can have a semicolon, and it'll work fine with the new line too. But you can mix and match. You can have a semicolon. You can have a comma. It's okay. It'll all work just fine. So let's just go ahead and make it like that. And there it is. There's our matrix B. Now, as mentioned, you'll commonly see matrices denoted with a capital letter like this, but in Octave, any variable, like the ones we've seen before, can also be a matrix. So don't feel beholden to that notation just because it's how matrices might often be written by hand. If you have a specific matrix in mind and you want your variable name to be more descriptive, it can be anything. So if you say, my coolest matrix, I'm going to give the name cool matrix because this is just my coolest matrix, and it's 1 2 3 4 5 6 or what have you. And now this is just as valid as this in terms of Octave, so don't feel beholden to this notation of a capital letter. But that said, you're often going to see a capital letter denote a matrix, so no harm in doing that yourself as well. Okay. Another note with matrices, if even one element has a decimal value, everything in the matrix is going to have a decimal value. And so just to show you again with my cool matrix, if, you know, you have, if it's now 1, 2, 3 point, you know, some number, negative 323, 999, 1, or what have you. Okay, now, even though all of these are integers, right, it has one single value with a decimal place, and so that's going to flip the entire matrix. Notice, you know, again, how we have these this number of digits no matter what. It seems like that's what it's rounding to. You can actually format that, so you can make it, I believe it's 15 significant figures if you do format long, and then, I mean, you know, you can do this with your matrix, and that'll give it more significant figures. So, for example, if it's format long, like pi or something, it's going to give you pi with more significant figures. Format short, it's going to give you fewer. And in fact, the format short is the default, so if you just do format, it's going to go back to that default. So that's just one note. You know, I've mostly been working with integers throughout this, but I did want to point that out. Okay. So vectors is the next thing that I want to talk about. If we have a matrix with only one row or only one column, as we saw before in our vocab list, that's called a vector. So it's to the order of 1 by something or something by 1. And we make that just the same way we did before. If you want to be the vector to be one row, you can separate it out with commas or spaces. So like 73 to 0, you know, that is your vector with one row. Or if you want it to be one column, you can separate it out with semicolons, because remember, each of these semicolons is your way of saying it needs to be another column, and that'll work. Or of course, you can also, just as before, you can, you don't have to indent, but you can make it like that, and there it is. You can also transpose a vector with an apostrophe, and that's essentially turning a column to a row or a row to a column. So we see we have our vector v, and it's a column. If we wanted to make v apostrophe, that's going to make it a row. And in fact, if we made v equals v apostrophe and then suppress the output with semicolon, later when we wanted to bring up v, now it's going to be the row because it transposed it. And, you know, you can transpose it right back if you want, and make it a column again. So that's one nice little manipulation you can do. So there are shortcuts to make a range of values for a vector with or within a matrix. So if you wanted a vector, say, if our vector is called like cool vector, and I don't know, and you wanted it to be a range of values. Say you wanted the values between 4 and 16 going up by 1 each. So that's 4:16. This colon is your way of designating a range, and the increment that it's going to go up by default is going to be 1. So now it's 4, 5, 6 all the way to 16. And here's actually where your semicolon can be nice, because what if it was like 4 to 1,000? Well, you don't really want to print 1,000, right? But you can store it inside cool vector with this semicolon, and it works great. So for colon 1,000 is now stored inside cool vector, but it's not going to print it out or anything. But let's go back to 4:16. So you see how this is going up by 1 each. What if we wanted to go up by 2 each, or 10 each or something? Well, you can change the incrementation that it goes up by with another number in the middle. So let's make a new vector, and we'll call it cooler vector. And let's call it let's put in there 4:2:16. And what's this going to do? This is going to say a vector between 4 and 16 going up in increments of 2. This middle number is the increment. And it does 4, 6, 8 all the way to 16. You can also do ranges of values within your matrix as appropriate, right? So if you wanted to do cool matrix, and you can do 1:6, and that's going to be your first row, say, is going to be the numbers 1, 2, 3, 4, 5, 6, right? It's just a faster way of saying that. Semicolon for your new row, and then say you want to do 2:2:12, and now the second row is going to be the numbers 2 to 12 going up by 2. And you can do this, you just have to be careful that whatever shape you're eventually making is eventually going to be a rectangle, otherwise it's going to be angry and throw you an error because a matrix has to be a rectangle. So the length of these rows should be the same, and in this case, if my math is right, it should be, and it is. Okay, so that's 1 through 6, and then 2 through 12 going up by 2. And it's a rectangle, it works just fine, and you see you saved yourself a lot of time because you didn't have to write out, 1, 2, 3, 4, 5, 6. You can also, another way to save time or to just combine things is you can combine vectors and matrices together. So, for example, if you have vector _1, remember the underscore, because it has to be, the variable name can't have a space in it. Vector 1 equals like 5, 6, 7 or something. And vector 2 is 4, 7, negative, oops, need brackets, 4, 7, negative 14. Okay, and let's put in semicolons so we don't get a ton of outputs. If you want to combine it into a matrix, my matrix, you can make it vector 1, semicolon, vector 2. And this should make sense because remember what we're doing. What we're doing is we're just storing this vector into this variable. These two are the same thing. They're different means of expressing the same thing. This vector has stored inside it the vector 5, 6, 7, and this variable has stored inside it the vector 4, 7, negative 14. So why not have a matrix that's one vector, semicolon, another vector, right? If we run this, see, works fine. Again, just make sure that whatever you're doing is eventually going to be a rectangle, otherwise it won't work. There are several functions that are devoted to analyzing vectors and matrices as well. Earlier we saw some of the basic mathematical functions. Now let's talk about some of the functions that are really dedicated to vectors and matrices specifically. Two that are perhaps useful to know are length and size. And so the length, which you'd usually use with a vector, will tell you how long the vector is. That is to say, the number of columns, like that your row has, or the number of rows that your column has if it's the other way around. And size will tell you the order of your matrix, which is the number of rows by the number of columns. So keeping with the vectors we just made, the length of vector 1 and the size of, say, my matrix, the length of vector 1 is 3, which makes sense, right? 1, 2, 3 was the length of that vector. And the size of my matrix, it's a 2 by 3 matrix. It has 2 rows, right? 1 row, 2 rows, and it has 3 columns, 1, 2, 3 columns, and that can be useful, especially if you're dealing with really big matrices. You don't know, you don't want to count. You can just see what size it is, just like so. Another fun thing here is that, this answer, once again, of size, is itself a vector. So, it's a vector of 2, 3. So if you did like length of the answer, you see it's a vector with the length of 2. So because remember, when it has answer like this, ANS equals, it's just storing whatever is the most recent thing inside the variable ANS. Okay, so now let's talk mathematical operations with matrices. Recall back at the start of the video, we discussed the operators and how you can sometimes see like plus versus dot plus or times versus dot times, and I told you, don't worry about it, we'll talk about it when we get to matrices. Well, here we are, we're talking about matrices, and this is where this is going to be really important, especially with the multiplication. With the addition and subtraction, it's not that important still, to be perfectly frank. But let's talk about what happens when we do operations with matrices, and that will hopefully start to make a little more sense. So first, let's start with addition and subtraction, which is the same, so I'm just going to show you as an example addition. So, when matrices have the same order, that is to say they're the same number of rows and the same number of columns, they're the same size, then you can add and subtract them simply by adding or subtracting the corresponding elements. So you see in the picture here, we have the matrix that I had saved as matrix A, and the matrix I had saved as matrix B. See, you were wondering why I was being so meticulous with what I was giving those variables and why I never deleted them, because we're using them. And so we have our matrix A, we have our matrix B, and we're adding them together. And if you were to do this by hand, which don't recommend, but if you were to do this by hand, it's just a matter of taking each element and adding it by its corresponding element. So 8 plus 4, right? 7 plus 6, there. Okay, all the way to 29 plus negative 93, which is the same as saying 29 minus 93 to get you 64. Okay, and our result is this new matrix, which has each element by element, is the same as doing the matrix by matrix for addition and subtraction. So let's go back to CoCalc, and we'll see it in action. So let's delete out all this, because all I really want right now are my A and my B. Okay, so remember we have A, and we have B, so all we have to do, A plus B, and I'll also show you A dot plus B. This is matrix by matrix, this is element by element. With addition, it's actually going to be the same. As you'll see, it's presenting you with precisely the same matrix, because that's just how the addition and subtraction works. And hopefully my math was right here, and it was. So 12, 13, 10, 1, etc. 12, 13, 10, 1, negative 29, 6, 2, negative 64. Yeah, it looks like it's all correct. Okay, good. And so that's good, and that's one way to do it. Another way you can do it is just with that plus function that we saw before. You can actually do plus A comma B. Remember, this is the same thing as actually this. It's the same as the element by element. There isn't a specific matrix one because it's the same as far as I know. And it gives you the addition of these two matrices. Great. What if we had a matrix that was not of the same order? What if we had a matrix called C that was just like 1, 2, 3, 4 or something? Okay. Could we do A plus C? Yes. Okay, but could we do A dot plus C? Yes. Let me see. Oh, I see the problem. Okay, so this actually will work, but what if it was a 2x2 grid, not, Okay, so now say this is C. A plus C. actually will not work for you, because generally speaking, you cannot add these non-conformant matrices. The matrices do have to be the same order in order to work. Ignore the vector that I had before, and let's just work with the matrix, this matrix. Okay, so that's just an important thing to keep in mind, and why you might be getting an error. You'd also get an error with the element by element. It won't work. Okay. What about multiplication? So multiplication with matrices is trickier than addition and subtraction, but not impossible, and is made easier by using a program like Octave. So let's start with a simple example, scalar multiplication. When we multiply a scalar by a matrix, and remember a scalar is just a matrix of one element, so like 3 times a matrix, all we need to do is multiply everything in the matrix by that scalar. So in this example, if we took 3 times the matrix, I believe what we have for our matrix B, it's going to just be a matter of multiplying 3 times each and every element of that matrix, and it'll output a new matrix. So let's go back to CoCalc and try it. I think that was B, so let's do 3 times B. And there it is, right? 12, 18, 24, all the way up to negative 279. Let's see if this is the same. It is. So you see it just multiplied every single element by 3, and it produced a new matrix. Works fine. But now let's talk about the 2 different ways to multiply matrices, element by element and matrix by matrix. Perhaps the most complicated topic of the day, but no worries, we'll get through it. So when we talk multiplication with matrices, we need to be careful because there are 2 entirely different things that could be done. One is element by element multiplication, which is just like what we saw for addition and subtraction. It's just a matter of having our matrix A, having our matrix B, and we're literally just multiplying each element by each element to get a new matrix. So 8 times 4, 7 times 6, 2 times 8, etc., all the way up to 29 times negative 93. And you see I have the dot star here. This is where it's really important to have the dot star, because that's going to signify element by element. So if we do A dot star B, that's going to give us this, 32, 42, 16, all the way up to negative 2,697. And there it is, right? And so that's element by element, each and every element, just like addition and subtraction. Okay, but usually when people talk about multiplying matrices together, they're not talking about element by element. They're talking about actually multiplying the matrix by the matrix, and that's a much more complex process. As you can see on this next slide here, it's a whole to-do. First, if you were to do this by hand, it's a huge pain. First, all of the columns in this first matrix has to equal the number of rows in the second matrix. So you see I actually had to make a new matrix here, which we can, consider to be matrix B for this example. And then you take each element in the first row of A, right, and times each element of the first column B, and you add them together like so. So it's like 8 times 4, 7 times 483, 2 times 19, 0 times 11, and then you add them all together, plus, 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 and then all of that is just to give you this first element of your matrix, and then you need to do it with everyone. So to get this, negative 1607, it's, negative 48 times 8, 2 times negative 3, right? And it's a huge pain. You have to do this whole thing just to get one outputted matrix. And notice that because we're dealing with the rows by columns here, it's not commutative. Matrix A times matrix B is not the same thing as saying matrix B times matrix A. So that's a trap that for the unwary. So be careful with that. So let's do it in CoCalc. I need to make a new matrix, and let's just call it C. And the new matrix C is, I have it written down here, it's 4, 6, 8, 483, 39, -3, and 19, 4, 1, 11, 0, -42. Okay, and so you see that's our new matrix C. All right, and so now if I were to do A, which is this one here, right, which I think is what we used, 8720, yes, so A times C, and remember, we're not doing the dot times, we're just doing the times, and then it's going to give me my new matrix. Let's see if the math is right. 345, 329, 45, all the way up to -1607. Yep, works out great. Okay, so you see that's A times C. See how much faster that was? It was blink of an eye. Fantastic to just be able to do this in Octave like that. Much easier. You can also do functions here. Remember how we had plus A comma B here? If you can do for the dot times, so remember we had A dot times B is the same thing as just doing times A comma B. So this actually gives you the same result, right? And then same thing with A times C is the same thing as M times. M stands for matrix, I assume, A comma C. Should give you the same result, and it does. So that's another way to do it. If you don't want to use the operators, you can certainly use this function instead. Okay, and then division is similar to multiplication. If you wanted to do, actually A and B will work with division, so let's just write out a few of these. If you did so here we have A dot slash B, which is the element by element division, and it's the same as saying R divide A comma B. It should give you the same result, and it does. If you do A divided by B, and that's the same as MR divide, I know it looks like Mr. Divide, but matrix right division, so to speak, MR divide AB should give you the same result, and it does. Okay, and then the same thing with the left division. If you do A backslash B M L divide, and you can do, you know, the dot backslash and the L divide as well. It'll work fine, but I'll show you this. Works fine. Okay. So, notice, you know, that when it divides it, the element by element, like so, you know, just notice that it's giving you all these decimals. As before, if there's even one decimal, even though this 0 could just as easily be 0 as an integer, just because there's some decimals, they're all going to be decimals. So that's why it's displaying like this. You know, when you divide by 0 in Octave, I just want to show you this. If you do like 3 divided by 0, it's going to give you a warning, but it'll actually give you an answer of infinity. I wasn't sure if one of these was going to come up, but I guess not. But, you know, it's actually going to give you infinity, which isn't technically correct mathematically, but it's way better than, you know, just it throwing you an error. Like in Python, it'll say error, divide by 0. You can't do it, and then it breaks your whole program. Unless you're using like SciPy or something. I digress. But anyway, so that's actually kind of nice. And And so that's just one thing I wanted to show you, because I was kind of expecting a division by 0 to come up, but I guess not. Okay, so there's several special matrices that you can make with some built-in functions, and I'm just gonna run through them. You know, we're gonna do our cannonball run here of some of these special matrices. Let me delete out all this jazz just to make it a little cleaner. Okay, so let's do ones, zeros, I, rand n, rand I. Okay, so I haven't put arguments in, except I put in one argument for rand I, and you'll see why. But each of these takes as arguments rows and columns, and we'll see what each of them do. So let's say we wanted a 5x7 grid in each of these, except for the I identity matrix I, which I'm going to make a square matrix, which you'll see why. But everything else, let's make it a 5x7 matrix. And you do just the arguments of, and that's the number of rows, comma, number of columns, and that's consistent throughout. We'll see a difference with the rand I. And let's run the cell, and then I'll walk you through what each of these did. Okay, so first we have ones. 5x7 makes a 5x7 matrix of just the element 1. 1, 1, 1, 1, 1. Okay, and that's great. Zeros is exactly the same thing, but with zeros. And so that's going to give you a matrix of all zeros. The identity matrix. This one actually, you know, it'll give you some, like, it'll give you an output. It's not going to give you an error if you don't give it a square matrix, but the secret to the success of an identity matrix, which just means a matrix that you can multiply by another matrix to get itself back. So like you know how like 3 times 1 is 3, and you can say that 1 is the identity. For a matrix, like the matrix A times the identity matrix should be, you know, just A back, right? And so the secret to its success is that it has this diagonals of 1s. That's why it works. And so that's why I did it with the square matrix. Anyway, and so IEYE gives you, I assume they did that part, you know, just because the capital I is already taken by an imaginary number, or the lowercase I is already taken by an imaginary number, and so wouldn't make sense to make it identity as well. So they just kind of sounded it out with I. Though I don't know, if you are on the Octave dev team, leave a comment and tell me why this is called I. But anyway, it's the identity matrix. And then what was our next one? Rand gives you random values between 0 and 1. So here it's a matrix of random values between 0 and 1. Rand n gives you random values between -1 and 1, what's called the normal distribution. The n in rand n stands for normal, I would assume. And so then we have a very fun one here and a very useful one, rand I, which gave me random integers. And because rand I is random integers, as opposed to these other ones, which are just automatically between, like, you know, -1 and 1, or between 0 and 1, the random integers, you have to set what the range is. And by default, it'll go between 1 and whatever number you set in this first argument. So I did 100. And it gave me random integers between 1 and 100. If I wanted to make it a range of my choice, I can use brackets. So if I wanted to do random numbers between 5 and 15, I can do that inside brackets like so, and then a 5x7 matrix. And now it gives me random numbers between 5 and 15, and you see it includes as possible outcomes the 5 and the 15. So it's between 5 and 15 inclusive. As demonstrated by the fact that we have at least one 5 and a few 15s popping up. Okay, so if I just wanted a random number, you know, like a random number. By the way, I can get rid of these. Why don't I just do this in the same one? I can just get rid of these arguments, the 5 and the 7. And if I want a random number between 5 and 15, it'll give me one. So, if I run it again, it'll give me something different. It's not always going to be 5 and 15. See, now it's 7. It'll give me something different every time. Okay, so that's one way to generate random numbers in Octave. This is a scalar. It's a matrix of 1 element, which is actually how most numbers work in Octave. So that's handy. Okay, and then the last thing on matrices is how do you access a particular element of a matrix? Well, you can use what's called an index expression to reference or extract a selected element of a matrix or of a vector. And this can just be the name of your matrix. So, we have a couple of matrices defined here, A and B. So let's just go ahead and use those. Let's use A. So the name of the matrix, which is A, parentheses, and then inside these parentheses, just put the coordinates that you want, row, comma, column. So if you wanted, let's print out A again, so it's handy. So if you wanted the third row, 1, 2, 3, and the second column, 1, 2, should be the number 2. Let's do 3, comma 2, and you're golden. There it is, 2. You could also use your colon again to get a range here. So if you just wanted the third row, and the second 2 through 4th columns of the third row, you can do 3, comma 2, colon 4. So now this is going to look at the third row and then the second through 4th column. And there it is, 2, 1, 29. Okay. A handy keyword here is the word end, to just go to the end. So if you wanted the entirety of the third row here, you can do, and you didn't know offhand how big it was, and you just wanted to go all the way to the end, you can do 3, comma 1, colon end. That's the third row, 1, all the way to the end. And there it is. That's the whole third column, and it's now saved as a vector, by the way. Remember that. It's a vector, right? So that's handy. Okay, and so that'll give you the whole third row from the first column to the end, and this can be useful if you wanted to sum up an entire row or an entire column. Then you can use a function called sum, A, 3, comma 1 to the end, right? And so here we have sum of this entire third row, negative 16. And remember, we didn't have to do that because it was stored in our variable answer, so that should give you the same thing. Anyway, but I digress. So, you can multiply an entire column with like prod a 1 to the end, comma 3. And what's this going to give you? It's going to give you the product of everything in the third column, right? So that's 1, 2, 3. 2 times 23 times 1 should be this, right? And it is. And so, there you go. So that's just one quick way. So you don't have to manually type out 2 times 23 times 1. You can just do the product, prod, of the matrix A. First argument is the row, and we're looking at 1 to the end, right? So all of the rows, basically. And then column, the third column. So the third column, 2, 23, 1, same thing. Okay. And that is it for matrices, and in fact that's it for Math with Octave. So now we're going to move on to the second part of the video, which is using GNU Octave as a bit more of a general purpose programming language, though everything in this part of the video will also be just as useful, even if you're just planning to do math with the language. So I do hope that you stick around, even if you only have designs on doing math with Octave. And even if you only want to use Octave for the matrices, do stick around. It's all applicable. So we're going to go through making and using strings, getting using user input, writing your own function, conditional statements, loops, and comments. And I think that's everything. So let's clear out everything and just start afresh. Okay. Strings. In general, in programming, there are different types of data, some of which could seem to a human reader to be the same, but in fact, to a computer, it will be quite different. So in Octave, there's a function to tell you what type of data you're dealing with, and that's called type info. And then as an argument, you can put in whatever data you want, and it'll spit back what type of data it is. So let's let's make a few of these. It just ran it for the blanks, but that's fine. So 3, let's do 3.4, some decimal. Do pi. Let's do 1, 2, 3, 4. 1, 2, 3, 4. So remember, this is our vector. This is our matrix. Okay, but what's it going to say when we do the type? That's the question. Some text 1, 2, 3. And in double quotes. And then in single quotes, more text, blah, blah, 1, 2, or, oops. Okay, so what do we have here? Well, we have what you might think of as, if you're coming from like a Python background, you'd say, oh, I know, it's going to be an integer and a float. Well, let's see. So we have 3, 3.4, pi, which is going to be like 3.14, our vector, or matrix, some text in double quotes, some text in single quotes. What's it going to say is the type of each of these things. Aha, well, it's telling me, yeah, all these numbers, pi, and this, and all that, they're all scalars. They're all an element in a matrix. The vector, yeah, that's a matrix. And the matrix is, of course, also a matrix. And this just shows you how matrix-oriented Octave is, And then finally, we get some variation here. We have string, and we have SQ, stands for single quote string. Okay, and what is a string? A string is, you can think of it like plain text. You can store a string inside a variable, just like anything else. It can be with a double quote or a single quote, though do take note, it's counting these as different types, and in fact, they behave a little differently. I'm just going to really be working with the double quote strings, but, we'll keep that in mind. And it's just kind of plain text for, like a human reader, but the machine will take it and store it as data, but, it's really more for human consumption usually. It's just text. And also note these quotes, the double quote and the single quote, these are straight quotes. If you're copy pasting from Word, a bunch of curly quotes and smart quotes from a modern, word processor like Microsoft Word or something, not going to work. Has to be a straight quote, like you would get in Notepad. Okay, so let's play around with these strings. So you can store a string inside a variable, just like you can with the numbers and matrices we saw earlier. So if you have a variable myString with the equal sign, just like we had before, and we have hi there, cool people, and then let's add a semicolon just so it's not gonna, just to suppress the output just for now. And if I run this, what's stored inside the string? Well, what's stored is my message to all the cool people, that is to say to you, the viewer. So when I put that variable in later in my program, it's going to show me, it's going to display the output. And if I didn't want this myString equals, if I just wanted to display the output, I can use a function called disp, or display. which is similar to like print in Python and other languages. And that's just going to print the string as the output. So, you know, that's going to display it. So, of course, you know, the classic program, the classic beginner program is hello world. And that's how you would do it in Octave. It's just with disp, right, with your string. Okay. And that looks a little bit better. So you can manipulate the strings as well. You can add them together by putting them in a list. So, for example, if my string is in brackets and it's hi there, comma, let's do hi there, comma, cool people. And let's add a quotation mark there. Okay, good. So you see what I did here is I have a string inside brackets. Okay, and inside those brackets I have a string hi there, separated by a comma. And let's put a comma here too, just to show you. When the comma's inside the string, it's just part of the string. But when it's outside the quotation mark here, it's actually adding these strings together. Then I deliberately put in a space because the comma's not going to add a space. And then our second part. And so if I run this cell, now this is stored inside my string. And if I run this again, it's going to be the same thing. If I wanted to add even more, I could. Hi there, cool people. How are you? I don't know, whatever. So now, if I just ran the cell with Shift Enter just to store it again. And there it is. You see, it didn't add a space, and that's important. So you need to add the space somewhere, just to make it go. And you can run all this. I'm doing this a little slowly. You can just run all the cells like that. Okay, and so it did what's called concatenating them all together. And so with a double quoted string, and notice this, and this won't work with a single quoted string, but with a double quoted string like I have, you can format it, and you can add different things with what's called an escape sequence. You can use a backslash. I'll give you an example of a few of these just to show you. Though they're all listed in the documentation, and they are all the same as those found in the C programming language, if you're familiar with that. If not, not a big deal. So let's do these all as displays. And let's do hi there, and then \n cool people. And let's do another one. Let's do \t, and I'll explain what all these do once we run it. And then one more. Let's do my favorite character is the \. Okay, so what's going to happen when we run this? Notice we have these funky things that kind of stand out. It's a \/ with a character after it. It's called an escape sequence. Let's run it. Okay, so the first one, the \n, made a new line. Hi there, new line, cool people. The second one, the \t, gave us a tab. It tabbed it in and displayed it as hi there, cool people. And the last one, the \\, it actually printed a \, which you wouldn't have been able to do if you just had the one \, because it would read it as an escape symbol sequence. So the \ is necessary to print a \. So you see it only printed a 1. Okay, you can undo these escapes if you didn't want the escapes sequence. If you actually wanted to print out what's here, the \n, there's a function for that. It's called undo string escapes. And I'll just show you with one of them. I won't beat the dead horse. And you see it undid the string escapes. It gave you hi there, \n, cool people, actually printed to the display, and another \n as well. Why did it do that? I'm not sure. I'm not sure why I put this in. Let me know in the comments if you know. Okay, but anyway. You can also make a string of blanks with the function blanks. So if you do like blanks 40 or something, it's actually going to print 40 blanks as a string. So, you know, like 40 spaces. It actually prints the characters. You can't see it. You know, like there's a whole programming language called whitespace, which is just whitespace. So this would be perfect if you wanted to sneak in some whitespace code inside your Octave code as a secret message. But other than that, if you did type info of what we just stored in our variable answer here, it's going to tell you it's a string. It's just a string of blanks. Okay. So now let's talk about formatting strings. And you can actually put some placeholders inside your string. You can use a function that will be familiar to those coming from a C background, but a little cumbersome from those of us who might come from a little bit more of a Python background and are used to like the Python F strings, which are really nice right now, where you can just plug in a variable very quickly. But what we're going to do is we're going to plug in variables into our string, and we're going to use what's called sprintf. The function is called sprintf, and the S stands for string. Print is like printing output, like we did with display, and F presumably stands for formatting. And how it works is you put your string inside these parentheses. So say you have, we were 2.3 miles from Philadelphia and could already smell the cheese sticks. Okay, so say that's what you wanted to display, right? And, you know, it'll display it. You can put it all inside display if you were so inclined to make it a little nicer, but no need. Okay, so say this is what you're displaying, right? What if you didn't want to be 2.3 miles from Philadelphia? What if you wanted this to just be a variable with your number? So what you can do is you can make a variable, call it num miles, and I know. You tell me in the comments how much better the metric system is. I'm an American, and that's what I'm used to. So what's what we're doing? I appreciate that the metrics that kilometers are better. I understand. But anyway, so the number of miles 1.2, and let's add a semicolon just so it doesn't print out all of our variables because we're going to add more. And then instead of 2.3 miles, let's put %d, the % to show we're about to put in a placeholder for a variable instead, and the d to show that the variable is going to be a decimal value. The type of variable matters here. And then after your string, you put in a comma, and then the name of the variable, in this case num miles. And that should plug in when you run the cell with Shift Enter. Now we were 1.2 miles from Philadelphia and could already smell the cheesesteaks. Delicious, delicious. Okay. But what if we aren't going to Philadelphia? What if we're going on a scenic trip to beautiful Western New York, home to my beloved Buffalo Bills? Well, what we can do is we can have city and we can have food. So if we have city equals Rochester, and food, let's put in some of my favorites. We'll put it in quotes because it's a string. And food, let's put in some of my personal favorites. Let's do garbage plates and beef on whack. And a new line, or Western New York dreams were about to come true. Actually not a period, because there's already a period, I think. Oh, no, there's not. Okay, so let's do that. Okay, and a semicolon. Just so we're not, it doesn't matter. Well, anyway, and so now let's go ahead. Actually, yeah, let's put in the semicolon, though. This is going to be a bunch of nonsense. Okay, and now let's go ahead and change Philadelphia to %s S for string, and the cheesesteaks with %S, S for string, and then num miles, comma, city, comma, food. What is this? This is, we were %D, we were the number of miles, right? Num miles from Rochester, okay? And we could already smell whatever we're storing into food, which is this whole sentence. Let's run the cell. Okay, so here we have it, or answer, so to speak, which is actually stored in the variable answer here. We were 1.2 miles from Rochester and could already smell the garbage plates, real food, and beef on weck, or Western New York dreams were about to come true. Go Bills. Okay. And if we wanted to make this a little nicer, now that it's stored in answer, we could have put semicolon here just to store it inside answer, and then just do display answer, and then it'll display it in a little bit of a nicer format. So that's the sprintf function, just to fill in blanks with variables. Just keep in mind the type of data you're dealing with. If you're coming from a Python background especially, it's going to seem like it's a huge hassle, but it is what you need to do. So just bear in mind whether you're plugging in like a decimal value or a string. So next, I want to discuss how to get input from the user. And let's just clear everything up. Because getting input from a user, it's very important if you're making a program, right? You could make it a variable, and inside that variable, store something from the user. So, if you put in like the variable like my number, then you can put in the prompt input, and in quotation marks, a prompt for the user. Give me a number. And, this is different from Python, which will take it as a string. In Octave, which somewhat makes sense since it's, a very mathy kind of programming language, it will assume, unless you tell it otherwise, that the user's input is a number. So then, it's going to prompt the user to give you a number. And if we do that, if we say 2, it's going to store that number inside the variable my number. And then later, if we wanted to display it, it'll display the number, right? And so that's input. It's just input with parentheses, a prompt in quotes, and by default, it'll take a number. So you can do a program with this, right? If you said, input, give me a number, and I'll tell you its square root. And you see how you can make a little program here, because then you're going to change the variable to become, let's actually do this. Let's not change variable, let's make it a new variable. Let's make a new variable called square root of number, and then let's put in a semicolon so to suppress the output, and then we'll display that new variable. Okay, so this, I know I just did a lot, but let's run it and I'll walk you through it. So, give me a number and I'll tell you its square root. What's this? Well, we are taking an input. Give me with the prompt, give me a number and I'll tell you its square root. Gives you this box for the user to put in an input. It'll store that input inside the variable num. So let's do, 81. And then when we hit enter, it's going to then take the square root of the number and store it into a second variable called square root of number. And then it's going to display square root of number. So 81, and there it is, 9. Okay, so that's perfect. So it did the square root, and that's a program, right? It took a value from the user, and it gave it a square root, all just with this input. All right, so that's to take an input that's a number. What if you wanted an input that is a string? Well, that is going to take something a little different. Say you were writing a text-based adventure game in Octave, which is always a fun thing to do. If maybe the first thing your user sees can be written like this. Username equals input, what is your name, comma, S in quotation marks. The S in quotation marks is for string, okay? And then you can just display, let's do the sprintf again. Hello, %s, remember to be our placeholder for username, and welcome to my game, comma, username, because that's the name of our variable that we're filling in, %s. And when we run it, what's your name? MCC Pi Tutorials. And it's going to say, hello MCC Pi Tutorials, and welcome to my game. Perfect. Okay, so that's input from the user. The next thing I want to talk about is writing your own function. We saw there are a lot of built-in functions, those words with parentheses after them that do some task. What if I wanted to make my own? I can do that by defining my own function. And I can do that, say I wanted a function that'll add 2 plus 2. I can write the keyword function, and let's write a name for our function, and let's just call it plus 2, for example. And I'm actually not going to put parentheses, though you'll see later you will want parentheses, but for this simple example, we're not going to need them. It'll work fine without them. So let's do 2 plus 2, and that's the body of the function, is just whatever you want the function to do. And then below that, and this is critical, you have to end your function, okay? And you do that with end function. Okay, and so that'll define the function. If we run it, it's not going to do the function, it's just going to define it. So next time I wanted to do 2 plus 2, instead of writing 2 plus 2, I can call that function by putting in the name of the function, like this. Plus 2. And there it is. 2 plus 2 is 4. Okay. I can indent to my heart's content. So, you know, those of you who are used to Python are probably more comfortable indenting this, and it does look neater, and it'll work just fine. I also don't need to make it new lines. I could separate these with commas or with some combination of commas in new lines. It'll work just fine. See? But if I were you, I would put it on new lines, and that is what the documentation recommends. Works just fine, separated by commas. You can mix and match. You can have commas and new lines. It'll all work just fine. What if I wanted a function, though, that just takes an argument and adds 2 to it? So this time, instead of just having a function that only does 2 plus 2, let's have a function that takes some value, some number, and then adds 2 to that value. So to do that, let's do function again, and let's call this one plus 2 as well, and put in parentheses, okay? And then inside the parentheses, let's put in some variable. It's okay that it's not defined yet. It'll get defined later. Starting num. And then you can hit enter, or again, you can do a comma or whatever. And you can indent if you want. You don't have to. Plus 2, parentheses, starting num. And then let's write in the body of our function what we want our function to do. In this case, it's going to take a variable called starting num and add 2 to it. Okay. And then, don't forget, end function. And that's how it knows that the definition of the function is over. So when we run it, now the computer knows that this is what the function does. And the next time I want to add 2 to something, I can do the name of our function, parentheses, and then, you know, whatever we want, 73. It's going to add 2 to it. And in fact, I can do this to my heart's content. I can make a bunch of these, right? I can do, you know, like pi and -29 and I don't know if this will work, inf, and 37. And as suspected, the infinity, you can't really add 2 to it. It's just infinity. But everything else, you know, it added 2. And I mean, it did go through the process of, you know, what would happen if you did inf plus 2. Anyway, and so you see, works great. Plus 2 is our new function, just like round was a function or plus was a function. Now we have one called plus 2, and we can use it as much as we like. So that's the basic syntax of a function. Obviously, you can make functions much more complex than this, but in a nutshell, that's how you do it. So next I want to talk about conditional statements. That's the if-then statements. And oftentimes when writing a program, you want the computer to make a decision and do something different based on the data given. So say we had a variable, and we wanted our program to do something different depending on what the value of the variable was. If our variable equaled 5, for example, say my variable, and let's store inside that variable 5. Let's press the output with a semicolon. Well, here we'll write the word if, and then whatever we want to do, whatever we want it to check to inform its decision. And you can do that either with a comma or on a new line. If we did if my variable is equal to 5, and these two equal signs, it's a Boolean sign. That means like is equal to, like not equal to would be with a tilde, greater than or equal to is like that. Okay, so that's, perhaps I should have covered that earlier, but that's just kind of a logical statement. So if my variable is equal to 5, then let's do the next thing. Let's display that variable equals 5. And so if this is a true statement, then display that variable equals 5. And we'll show you other ways to branch out this decision tree further, but just to keep it simple, we'll end our if statement with end if, just to show. Okay, and so now what's going to happen, whoops, the if has to be on the same line. There we go. Okay, so as before, that was an error on my part. Disregard what I had before. The if has to be on the same line, comma. It can be a comma though. That should work fine, but yeah. Okay, and just remember to end your statement with end if. And that's fine. If we didn't write the end if here, it wouldn't work. See, it gives you an error. So make sure that you end your if statement. Again, you can, you know, indent it to your heart's content. Or comma it. And so you can also put in a couple of other different options, some more branches on your decision tree, so to speak. So you can do a couple other things here. If you have something specific in mind, you can do what's called an else if statement. And so else if is just kind of a way of saying, you know, another option, so another specific option. So else if my variable is equal to, say, 8, then display that variable equals 8. Okay, so now if I run it, it's still going to say 5, because it does, but if the variable were 8, now it's going to say that variable equals 8. And you can put in as many else if statements as you want, but if you don't have something specific in mind and just have like a catch-all, that you can do with an else statement. And notice I'm not going to put in else, you know, my variable is equal to 9 or something. It's just going to be else, and it's going to cover everything under the sun. Display that variable equals something else entirely. And it equals 8, of course, because it equals 8. And if it were to equal 5, it would equal 5. But say it equaled, negative 928, or it equaled some string. That else is going to be able to handle it as a catch-all. Okay, so excuse me. You don't have to make this just equals. You can make it the other operators that we saw before. So if let's make this like less than negative 12 and else. And so then let's change this to that variable is greater than 5. That variable is less than negative 12, or that variable equals something else entirely. So now if it's like 90 or something, 90 is greater than 5. So it'll display. If it's, negative some number, it's less than negative 12, right? And if it's something else, if it's like 3, variable equals something else entirely. Okay, so you can use any of those Boolean logic statements. It'll work fine. So that's conditional statements, and next I want to discuss loops. And there's a few different kinds. Loops are good if you want your program to repeat a task. So let's talk about for loops, and then we'll talk about while loops, and then do until loops. First, for loops, which will repeat a certain number of times that you can decide some instruction. So, for example, if you have like for I equals 1 to 20, and this is just the range, I plus 2 and 4. What's this doing? This is saying for every time I, and I is kind of like it stands for index. It can be anything, it can be any variable here. It doesn't have to be the lowercase I. In fact, maybe it shouldn't be, because lowercase I is the imaginary number. So, maybe you shouldn't use I here. Actually, you'll often see it with I. But let's do for number or something. So for the variable number, for num equals 1 to 20, add 2 to num, and then end your for loop. Let's run it, and then I'll walk you through what happens. So when we run this, it's saying do everything that comes after this. Just input 1. So it's saying take the number 1 and input it for our variable num, and then add 2 to it. Then go back and input the number 2, and then go back and input the number 3, and go back and input the number 4, all the way to 20. And once you get to 20, then just stop and end for. And you see that's exactly what it did, because it added 2 to the numbers 1 through 20, and we end up with the numbers 3 through 22. So that worked out just fine. And as before, this can be separated out with commas or a mix and match of commas and new lines. It'll work just fine. Okay. And also, instead of a range of values like this colon, you can just have it loop through whatever you want. You can just make a list with these brackets, like a vector, pi 8 to negative 28, whatever. Add 2 to each of these and then stop. And it does. It adds 2 to pi. It adds 2 to negative 28. And then it eventually stops. And the nice thing about the for loops is you tell it. You tell it how many times to do it, and then it'll stop. The next type of loop is called a while loop. And this one, you don't tell it how many times to do it. You tell it to keep going while a certain statement is true. So if you have a variable like cool number equals 0, and so say you have while cool number is less than 5, which remember, cool number is less than 5 right now to start. While it's less than 5, while that statement is true, and it is true right now, take, cool number and make the new variable cool number plus 0.5. And then don't forget, just like with all these, you have to end it, and while is how you do that. And as before, you can do commas or whatever. Okay. And it did it. You see it. What it did is it just looped through. It said, okay, well, all right. Now, while cool number is less than 5, it checked, is cool number less than 5? It is, and 0. So let's do it. Let's make cool number to equal 0.5. And then it did. And then it looped back. Is cool number less than 5? Cool number is 0.5. It is. So it did it. It looped it back. Loop, 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 all the way to 5. And then it said, hey, cool number equals 5. It's not less than 5. I'm done. And it stopped. Just be careful, because you can, if you set something that's never going to be false, then you can be stuck in an infinite loop. There's ways to like halt and stop your programs on CoCalc and in Octave if you have it downloaded. But better to not put yourself in that position. So just something to be careful about. Then finally, there's a type of loop called do until. And do until is going to do some task until something becomes true, and then it's going to stop. So the way that works is you write do, and then, whatever's in the body, and then, so do, and then whatever you want it to be done. So let's do, let's make, number equals 0, and then do num equals num plus 5, and then until some condition happens. And for our condition, let's do num is equal to 50 or something, right? And so now what's this going to do? Well, this is going to say, okay, this variable number is 0. So I'm going to do this task. I'm going to start adding 5 to my number until the number is equal to 50, and then I'm going to stop. And it did, so you see, and it added 5 to each number until it stopped. One caveat is with these do until statements, the until isn't until the end. So, because it's going to execute these kind of starting from the top down, it can get confused. If your number is 50 off the bat, then it's going to start adding 5 to 50, and then the number isn't going to equal 50. I'm not going to run it because it's going to be a mess, but that's something to be careful about because it'll start doing it before it checks the until. But this is another type of loop, the do until statement. And then finally, the last topic is comments. I want to talk to you about adding comments to your code for a human reader. These will be lines that the computer is just going to pass right over, but a human being can certainly read. There's 2 ways to do it in one line. One is with this sharp sign, or a pound, or hash, or octathorpe sign. This is a comment. The other is with a % sign. This is also a comment. Octave is agnostic as to whether one is better than the other. This one's probably more similar to Python, so it's probably what I prefer. But, you can certainly do the % sign as well. And with these, the computer's going to pass right over it. So if you do, like some program and run the cell with Shift-Enter here, it's not going to do these comments. These are just for human consumption. So one common thing that people do with the comments is they write, kind of what something does, just over, what is going to happen, displays the phrase hello world, and you see it just displays the phrase hello world. It doesn't do the comment because there's nothing to do. It's just for the human. Okay, and then you can also use comments to comment out lines of code. So if you had display hello and display world, if you just and why don't I do 3 things? Hello beautiful Get my Jim Carrey on. Beautiful world. Okay, so then if you comment it out, which you can do with this or with this, either one will work. It'll only do the one that's not commented out, right? And it's just going to display the word hello. You can also have blocks of comments by enclosing them, and this is not intuitive, so take note. With the sharp sign in curly brackets or the % sign in curly brackets, but the it's not symmetrical. So you're going to want these to be standalone lines. You know, this is my comment. I have so many people to thank. Billy always believed in me. You know, whatever. And so then none of that's going to be read because it's all a comment. Right? It's just going to do the program. And then the same if these are percents, but don't mix and match. At least I don't think you can mix and match. Let's try it. I guess you can. Well, anyway, I don't think it looks good if you mix and match, so I wouldn't. Okay, but notice these aren't symmetrical. Intuitively, you would think that if you have these brackets, it would be percent brackets and then brackets percent, but it's not. It's percent brackets and then percent closed curly brackets. So just be wary for that. If you did this with like as you might think of it as intuitive, it's not going to work. It needs to be percent curly brackets like that. Okay, well, anyway, so this is how you would do a block of comments if you want to put in, you know, the copyright information and like maybe an explanation of your code before anything, like a big chunk of comments. That's how you would do it. Or of course, you can also just do, you know, every single line with a percentage or a sharp sign before every single line as well, if that's what you prefer. Okay. One other thing about the comments, you know, they do need to be on the same line according to the documentation, just to parse. Let me try it without, just to see what happens. Yeah, see, it's parsing error. So you want these to be standalone. So you want these to be their own line. White space doesn't matter, but it'll be a parsing error if you're just enclosing it, you know. So just be careful with that. Okay, and that wraps up this tutorial on GNU Octave, which covered Octave for math, and then Octave as a more general programming language. This one took me quite a bit of effort to put together, so I really appreciate you watching it through the end. Thank you for that. And if you got value out of this video, you can show your support by leaving the video a like. It really does make a big difference. And I just want to thank you very much for watching, and I hope that it's helpful to you. Best of luck in your endeavors with Octave. Thank you.